everyone. I think that you can see my screen and you can see the presentation. So I'm going to talk about the ecological restoration of the Rhône River with the very tangible, concrete aspects, the way we carry out the restoration actions, and in interaction with the riverine residents. And just as a reminder, as it was said by Thomas, on anthropic pressure on the Rhône River, the two main morphological pressures date back to before 1860, with the first dikes, the embankment, the first ones to allow the populations to protect themselves from flooding. But mostly at the end of the 19th century, early 20th century, with work that was done by an engineer from the French state called Mr. Girardon, and his role was to develop navigation on the Rhône River. The Rhône, because of its flow rate, was difficult to navigate on. And so there was a major program to build the structures, as you can see on this photo. So on this photo here, you can see that a lot of structures were built to concentrate flow in the main channel of the river so that the Rhône would create its own navigation channel. Then the second major morphological pressure came from the building of hydropower dams on the Rhône River. They are run-of-river schemes, and they were built from 1900 to 86. And human intervention led to a uniformization of the Rhône River. The Rhône had many arms, and it ended up with just a main channel with no side arms. There are other types of pressure, such as water quality. A lot of work has been done in the last 50 years to improve water quality with wastewater treatment plants, where also we see the presence of micropollutants and endocrine disruptors that can act on organisms. And we're also studying climate change. We think that we'll have fewer water resources and increasing temperatures, and that's going to cause problems for the adaptation of organisms and the evolution of ecosystems. In terms of restoration, we're going to focus on the Rhône River that was cut off because of the hydropower dams. This is at the level of the dam. And on the Rhône, we call this the old Rhône. And it's on these areas where we see the greatest potential for restoration. There's resilient biodiversity, and we have these river structures that were made by man in 60 kilometers of the Rhône River. We have lots of what we call abandoned channels on the Rhône River. These potentials are huge here on these areas. And you can see on the slide the evolution that's taken place over time that's well recognized by scientists and river managers with this creation of the river systems. On the next slide, in this, we have the presentation of the restoration program. The Rhône, even if the science is new, this program is dating back to more than 20 years. In the early 2000s, we started with the objective to find a running and lively river, so to ensure that there would be minimum flow in the river. This was defined when the dams were built, and it could divide the river flow by 100. So it was a drastic reduction in the water resource that was available. And we wanted water to come back into these abandoned channels. And so work was done in 2000 in Pierre-Bénite, and then in the upper Rhône River in 3 geographic areas, Chotanne, Belay, and Brenier-Cordon. The same type of restoration work was done to increase the minimum flow and to connect abandoned channels, and this was done in Péage de Roussillon in 2011 to 2014. And there are other areas like Montélimar where the work took place between 2011 and 2015. Sometimes there were one-off programs that could take place depending on social demand. Along the Rhône River, there have been some projects farther south in Cadrousse, in the Arménie Channel. Associated with this type of restoration, there have been evolutions that have taken place over the last 20 years, and I'm going to present them more downstream or further in my presentation with a functional and morphological restoration approach to the Rhône River with elements that occurred in that led to a more physical restoration and more complete restoration. So today we're really looking at different water bodies in terms of the water framework agreement. So we have these hydropowered Rhône River hydropowered dams on the Rhône rivers. There are projects downstream of the Rhône River in Pierre-Bénite, where the first project took place with the opening up of 3 sites with the work done on the Girardon structures at the Péage de Roussillon. There was a project of more than 1 kilometer long to remove the Girardon structures, and then a whole series of water bodies that are considered as priorities in the WFD for good ecological water quality. So this is the median Rhône in Bourg-les-Valences and near Beauchastel, Bex-Logis-Neuf, and Donzière-Mondragon, where some operations have finished and the other ones are programmed for the coming years. As it was said in the previous presentation and also in the introduction, evaluations of actions are important in these restoration operations. And in these restoration operations, we have to give time to the projects because feedback and experience is important for the whole community of water managers, of scientists, of people with know-how about rivers, to allow them to improve the restoration process. So within the framework of this morphological restoration, we're going to look at reestablishing dynamic natural processes with the challenges of the different sites. Not all the sites have the same potential. So we want to find erosion and deposit zones. We want to free some space. We want to free the margins to give more alluvial margins that will benefit the aquatic, semi-aquatic environment, and also the land, which unfortunately was quite often forgotten in evaluation programs. So it's important to find banks that are as natural as possible and the habitat as natural as possible with levels of function so that the habitat can evolve on its own with the least human intervention possible later. In the different types of actions that are implemented on the Rhône River, we have the removal of these Girardon cages with the removal of embankments, as you see at Donzière-Mondragon. So there was rock fill that separated the sedimentation bogs with the main river. And in Cornas, we're seeing the removal of the embankments, so the removal of the rocks. There were a lot of these along the Rhône River, hundreds of kilometers of rock fill, longitudinal and transversal structures that were built. There are other examples of removing the rocks in Donzière-Mondragon. Associated to this, we also have seen opening up of some of the channels, and this is in line with our basic objective, was to bring a side arms and abandoned channels back into connection with the river. So here we're seeing channels that are essentially fed from surface water with hydrological regimes that are well dimensioned, and there are also arms that are channels that are fed from groundwater. And the scientists, in all of the work, assessment work that's done from the first campaign of the restoration since the years 2000, so more than 30 sites, they show the important role of all of these habitats in an alluvial floodplain. So associated with the main actions, which is to free up the banks of the Rhône River, we also want to inject sediment in the main bed. So active sediment injection, injecting material into the riverbed downstream of the dams. And depending on the scope and the actions carried out, there can be passive sediment injection. As we free up space, we're seeing erosion that takes place. And here's an illustration in Pont Saint-Esprit of the work that was done. So with the flooding of the rivers, we see that the gravel is injected into the river because of the high waters in the river. From an operational standpoint, this is an illustration of the different stages on the Rhône River. A geographic sector is different and countries are different, but in the context of the Rhône River, in this morphological restoration, we're starting with a master plan that was designed by scientists, the Observatory of the Sediment in the Rhône River. This was done in 2013. It's a founding document because it set the stage for the restoration and decided on the priority sites, the ones with the highest potential to remove the Girardon structures and with interesting remobilization of the Rhône River. Once all of the studies were carried out, in order to understand the Rhône, the interfaces with the ground use, diachronic studies, and also the specific power potential on the Rhône River, we started to understand the challenges of the territory. So this master plan of a priority water border from another was then rolled out into a feasibility study. And this was the first design stage in what we call operational engineering to carry out actions. This stage can vary. We start to frame our actions, evaluate, and for the project manager, we need to also evaluate the financial aspects because these operations are often very costly at the scale at which we're working on a river like the Rhône. And I think that's similar on the Danube River, given the size of this river. So we need to define the budget in the second stage. Then we go into the operational engineering pre-project phase. Then the project phase with contract management, where we'll draft the different contracts to carry out the work. Then we carry out the actions with the earthworks and ecological engineering, followed in the end by monitoring assessment that gives us feedback and improvement of the process. This period is something that a lot of project managers would like to shorten. I'm a project manager and I'm working on this on a daily basis. And these times sometimes are must stand as they are because we have to allow enough time to understand all of the challenges of the territories. So in the pre-project phase, we do inventories, we look at the sediment, the hydrological aspects, the real estate aspects. So I'm not going to list it all, but the list of topics addressed is very long, with environmental metrology also to carry out measures on the terrain, and also studying the sediment aspects. For the contracts, it takes 1 to 5 years. We define the project, but the restoration scenario is already decided in the pre-project phase. We look at the different possibilities. And in the achievement of the work, we mostly work in the winter time to respect the biological cycles, to respect uses. And so we work from October until February when the river level is the highest. So depending on the size of the operations, this can take 2 to 3 seasons. And then finally, of course, the feedback that we get that can last for more than 10 years. These operations are managed by the CNR, Compagnie Nationale du Rhône, where we have a program called the Mission of Public Interest since 2002, and we're currently in the extension of the concession, and there will be continuity, and we'll be setting up synchronous plans associated with this restoration plan. The work of scientists is vital. This program is very ambitious and of RhoneCo, and we start from the initial condition. We started in Pierre-Bénite 2000 with the tracking of the sediment. We look at fishing, we look at aquatic vegetation and the function of these different milieux. There have been reports on the life cycle of the restored areas for more than 20 years now. And this monitoring is being continued within operations that have been carried out since 2000, and it will be continued in the morphological restoration of the river with topics that will be added to the previous aspects. So we'll be looking at sediment and other points that I will address later. These operations are part of the SDAGE, the measurement program, with the measurement of the good ecological state of the water body associated with the Rhône River Plan. I just want to talk about some breakthrough events. The floods in 2002, 2003 were at 100-year return floods. So we had to look at the ecological approach in parallel with flood management. And farther downstream, we went on the Rhône River into areas where flooding can be much more important than on the upper reaches of the Rhône River. So this led to the triggering of mechanisms to set up another master plan, this master plan in 2013. We have the sediment crisis with PCBs, where we had to stop the restoration of the river in order to understand the interaction between the hydrosediment processes and the quality of sediment. And also, there's strong projects concerning sediment continuity for the last 20 years in terms of the management of materials that were moved during the projects. There have been huge evolutions in the methods that we use now for sediment management. Communication is also important with the different stakeholders, scientists, managers, users, associations, the local residents. So I'm going to now talk about consultation with our riverine residents. We're the manager of the Rhône River, the CNR, but there are many stakeholders that use the river on a daily basis with different activities. They could be fishermen, hunters, mountain bikers, association of protection of nature, teaching associations, boating associations. So we carried out an experiment in Pierre-Bénite. I just want to quickly talk about that on the slide. So within the design phase, we wanted to take into account the opinions of the users and co-build scenarios. I won't go into detail about the different stages, but we carried out the AVP, our project that took the design phase with the users and other associations, and we tried to collect their perceptions in the design phase. It was important to get their opinions, and we often were nourished by their vision of the Rhône River. They were attached to some heritage aspects of the river. They helped us define the actions. We restructured certain uses, certain pathways, certain little islands that would be protected. So this triggered mechanisms around how to resituate human activity in natural areas. We're close to centers like Lyon, where there's human pressure that can be very high. Pierre Bénite, more than 60,000 people can use the riverbanks. So it was important to build this project with the local residents to best take into account the uses of the different stakeholders. So we presented different scenarios, and we visit field visits. We didn't come with a defined project in the consultation phase. We really just wanted to share a roadmap with them, talking about the stakes of the morphological restoration of the river. This led to, on the roadmap, finding real islands in the river, and to have real secondary channels. And then we visualized in the field with the actors the situation of the site, and we discussed sediment reinjection into the main riverbed. So to finish on the strong points, take-home messages from this approach, I wanted to look at three focuses: the technique and assessment. We have growing challenges about sediment management and a lot of questions, and not always the answers. So we have to adapt our tools, we have to adapt our understanding and our knowledge. This is why it's important to have these study sites in order to capitalize on these sediment issues by taking into account all of the territorial aspects, in particular the industrial points, the flooding comprehension, to the fact that we're injecting rocks back into the river. That's not clear for everybody. Another important point was the challenge of the landscape and the trees that had to be integrated into the design. They live afterwards, and nature sometimes brings its own trees in. Sometimes they're invasive species, but there are also signals in the landscape. And there was a lot of discussion to see how we could reconcile this very important landscaping challenge, where we need to meet the expectations of our citizens to try to best meet their needs. The size of the open channels was important. This was something that was discussed with scientists to ensure that they would be sustainable, so that they could be fed by the main river constantly. And we also had to set up an operational follow-up post-restoration. There's, for instance, the interface with the forest that's important, and the presence of birds, which are great indicators on the quality of the restoration. Do we still need to continue to document sites to the same level of detail? So the territorial project with the development of the new Rhône, which is going to require support. We have erosion phenomena, things that are going to change over time. These are elements that we're going to have to respect. We go from the restoration to of a milieu that was static, and we're going to make it a dynamic environment with banks that will erode, and we see deposits of materials. So there's a lot of work to be done in the region to explain the restoration work that we're doing. We see this in all of our discussions. Sometimes it can be quite complicated because we have to restructure human access to the river also, and what the role of humans is in these areas with biodiversity. Lastly, we look at ecological transition and adaptation to climate change. We have to ask questions about these operations that we're carrying out. We have to have a low carbon approach, which means we have to evaluate the ecosystems prior to modification, the carbon that is contributed from the ecosystems and their role in capturing carbon, the addition of carbon, set up these actions, and the role of the new ecosystems in terms of carbon sinks. as well as aspects of integration of climate change, in particular due to the reduction of the volume of water coming into the river and the increase in temperatures. I'm sorry, I've gone slightly beyond my time.